Hello, this is the video for presenting the orange data mining. And in this video, I would like to continue the tutorial for the data pre-processing section 2 in the data mining course. In the slide, I gave you this figure to practice about the data pre-processing, and we learn about correlations and how can we reduce the data by PCA. And in this slide, I would like to explain about the data sampler and discretize. Okay, so let's go to the audience. And for this example, I just used the basic data, which is the iris. You know, there are four columns. There are four attributes in iris, and then one additional attribute to represent the type of the flower. And last time, I think you already learned about correlations. Okay, let's just do one more time. Yeah, if you have the correlation part, you can just connect between those two widgets. And yeah, you can see the correlation based on the person correlation. The petal length and petal width has the highest one. Petal length and sepal length is the second largest, and yeah, it follows the next to petal width and sepal length. You can use the person correlation, or you can use the Spearman correlation. Or yeah, you can try with only based on the particular attributes. Okay. And after you deal with the correlation, there might be some other widgets. For example, rank. I think I'm not sure I can explain all the things here. It means I can select the attribute. Okay, so if you still remember uh, one of the section discussing about the data reduction is about the attribute selection. So this rank can be one of the way to select the attribute. So if you can see here, there are many scoring methods like information gain ratio, Gini degrees, ANOVA. Okay, there is one chi-square. Okay, so you learn already the chi-square and relief IF, FCBF. Okay, I cannot explain all, but if you want to know, yeah, later you can check. And this one, yeah, you can see that chi-square. Okay, so the chi-square means the value that you want to see. Yeah, this one, it means the petal length. Okay, it has a very high chi-square. Oops. Yeah, and then the petal width is also very high. The sepal length is quite high, but the sepal width is not that high. Okay. So based on the uh, based on the lesson, we know that if the chi-square is high, then there will be a correlation about the values to be in the data. Okay. So in this case, the petal length has been figured out using the mean or the observation based on the expected value in that particular attribute. So the chi-square is in the rank, but for the other scoring methods, let me try to explain later. In some weeks later, we will learn about those methods, but not all of them. And the other, we want to see the PCA and discretize. Okay, so if you still remember, the PCA is a method to reduce the dimension. Yeah, it is one of the dimension, the reduction. And if you want to check the result, then you can just go to the data table and then check, and you will see that there are two principal components, principal component 1 and principal component 2. Instead of using the 4 attributes, you can just use the 2, and it will be enough using the 2 attributes because it represent the other forms. Okay? So using the algebra linear and using the eigenvalue approaches, so we can get those value, and those value are representative from the other four. And let's say after I finish the PCA, I would like to sampling. Okay, so there is one data sampler. So if you check this data sampler, okay, there's a data sampler from Orange. So you can choose only some data. So if you still remember in the section about the sampling, there are at least 4 types of sampling that you learn. Okay, do you remember? Okay, the first is the random sampling. So the random sampling is, yeah, in this Orange data mine, they use the proportion. Okay, if you want to choose 80% and 20%, then it will be split it. Or yeah, if you want to just choose, I want to choose the 80% among the data, then you can click sample data and oh, okay, I use the bootstrap. So if I click this one, fixed proportion of the data, then yeah, you can get only 120. And if you want to see the data, then you can just choose the data table and then check. Yeah, and then yes, you have only 120 data. You have only 120 data. And then yeah, originally, okay, if you check this one, there are 150. So if you select only 80%, then it will be only 120. There is also another data sample like fixed sample size. So I just want to choose 100. Okay, and then you still remember sample with replacement. And also there is another option. If you unclick this one, then it means it is a sample without replacement. So the sample can be selected again. And yeah, you can have the cross validation. We will learn this one later, and bootstrap. Yeah, we will learn also this one later. Stratify sample if possible. So if in the lesson we also learned about the stratify sample. It means we can group some portion of the data, and then among the groups we will select the random, or we just select the representative among the samples. So those are the data sample approach that are available in Orange dataset, in Orange data mining. And the last one that I want to share about the discretize. Okay? So in the discretize is also a good widget for us to understand. Okay? So in the discretize, we also learn many approaches in the discretize. So in the discretize, we learn how to do the binning. Okay, we learn also how to analyze based on the histogram. So we can just equi-width and equi frequency. Okay, so here there are some methods already available. You already learned from the slide. We have the equal frequency, and it mentioned the number of frequency or the interval that you want to use. So if you want to have a 3-pin, then yeah, just set 3. If you want to have the equal width discretization, you need to also mention the intervals. Okay, so if you still remember, equal frequency means each pin will have at least the same frequency. But for the equal width, you need to know the minimum and the maximum, and then it will be divided into 3, and then for each of the pin will have a particular range. Then if you set the 3, then it will be 3 section. Okay. If you want to see the result, you can just go to the data table and connect this one. Let's see, I'm using the equal width. What happened to the data? Okay, so the sample length, now we have the value 5.02 until 574. And the other data is less than 502, 5.02, and so on. So you can see the categorization is based on the particular range. Yeah? So it means it is based on the width. And you can check if I want to see the discretization based on the frequency. Okay. And Yeah, it seems it is the same. Okay, but yeah, you can check the other attributes if the because of the range is not that high. I guess there is no big difference. Okay. Yeah, petal width is different, and petal length and sepal width also a little bit different. But the sepal length there is almost no difference. You can also try to discretize, not for all attributes, but you can have the individual attribute setting. So if you want to do this with entropy MDL discretization, yeah, you can use also with this one. But of course, I cannot, I have not explained about entropy MDL. Okay. It's a little bit academic thing, so I just leave it for you. If you want to learn by yourself, then you can just learn the entropy MDL. So MDL is minimum descriptive length. Yeah, I think you can try to figure out about the leave numeric and remove numeric variables, and just leave the entropy MDL later. If you have the leave numeric, then it means the data will be still in the numeric. Okay. If you want to, okay, if you can see this one, leave numeric is for the sepal length and sepal width. Oh sorry, for the petal length and the petal width, it is leave numeric, but for the sepal length, yeah, because you select this one, so if you just the default, then it will be numeric as the original value. So this leave numeric is just the same with the original value, but if you want to choose the other, then you can just select, for example, you will leave numeric, or you use the equal frequency, equal width, or remove the attribute. Remove the attribute means you don't use that attribute for your further analysis. Okay, I guess that's all for the orange in the data pre-processing section 2, and I will stop this video now, and I will continue the other section with other video. Okay, thank you very much.